Assalamu alaikum dear students, hopefully you will be fine and you are watching on Professor Academy with Aftab Khan. If you haven't subscribed our YouTube channel, please subscribe and watch this video till the end. Let's go toward the topic. Actually, I'm going to prepare a formula sheet before starting of chapter vectors and equilibrium. Therefore, these formulas are very necessary to be memorized before going into the discussion of that chapter. Let's start from the first formula, which is about addition of vectors. If we have a two vector, let one is vector A and the other is a vector B, and we want to add A plus B, simply it will be equal to B plus A. It means that in physics the vector addition is just like common addition in arithmetics. Therefore, A vector plus B vector is equal to B plus A. So straightforward, this is the addition of vector. Further, we have a unit vector which can be written in this form: vector A is equal to A magnitude with A with K. Okay, simply a vector in physics is equal to the product of magnitude times to the unit vector. Null vector can be written as a vector plus with its negative vector is equal to null vector. I means that according to, inshallah, we will discuss in the next chapter with very detail, but here I have just write a simple formula for the null vector. I means that null vector is a vector in physics which is having zero magnitude and arbitrary direction. Therefore, it is known as a null vector, and here it is the formula for a null vector, or the representation of null vector. The next one is rectangular components of vectors. So if we want to denote or designate the components of vector in physics, we can write here that remember that here we have taken only the plane system or two-dimensional coordinate system. Therefore, we have taken two unit vectors ij. It means that rectangular component of a vector is equal to its horizontal component. Here I represent the horizontal component while j represent the vertical component of a vector. Therefore, a vector in its rectangular form can be written as a combination of its horizontal component plus vertical component. If you want to know more about rectangular components in space, we will write three vectors. Apart from this, I will add another vector. If you want to denote a vector in space in a rectangular component, we will write another vector az k, where k is show the space coordinate. Further, you must remember that ax is further equal to a cos theta, because cos associate with the component which lying on the horizontal axis, while ay it has been represented here as a sine theta, because sine theta associate with the vertical components for a vector in physics. So further you should remember this. The next topic, the next formula is a determination of vector from the rectangular components. If you want to determine the magnitude of a vector, or if you want to know about the direction of a vector in physics, we need these formulas. I mean that these formulas are very helpful in determination of vector from its rectangular components. Here there are two component vector, which is ax and ay, and it is equal to a is equal to under the root ax square plus ay square. From here does this it has been come from this formula that a square is equal to ax square plus a y square. And okay, and when we take under root on both sides, so we will get this shape of this formula. Similarly, if you want to know about the direction of a vector in from its rectangular component, we'll simply write here theta is equal to tangent inverse ay over ax. Okay, and the last formula here is position vector. Position vector r is equal to ay plus bj, where a and b are vector for a position vector r. You should know that what is position vector. Actually, position vector is a vector which gives us the position of vector in plane or the position of vector in space. So actually, if this is a plane system and this r will be the position vector, and we will know about ai, b, j. And similarly, if we further want to know about the magnitude, then we can write here that r is equal to a square minus b square. The next formula is about product of vectors. If we have two vectors, let's suppose we have two vector a and b, and we want to know about the scalar or dot product of these vectors. So we can write here that and we have already wrote here that a dot b is equal to ab cos theta. Remember that whenever we want to do dot or scalar product, we will get the cos theta with the dot. Okay, further, the unit vector in dot product or the product of unit vector will be equal to I dot j. Unit vectors product will be equal to k. J dot k unit vectors product will be equal to I. K dot I unit vectors product will be equal to j. Similarly, if we want to know about the dot product of the same unit vectors, like I dot I will get 1. Similarly, j dot j is equal to 1 and k dot k is equal to 1. You should remember this point is very important in the scalar or dot products. Further, we have vectors or cross product in this upcoming chapter. It is we have two vectors a and the other vector is b, and if you want to know about the cross product, we will get here that a cross b is equal to ab sine theta. Remember that one point is different here, that in a dot product we put here cos theta after multiplication, or I can't say multiplication, but I will say that after product, and in a cross b I will put sine trigonometric ratios in the cross product with in cap. In cap shows us the unit vectors. Especially here it shows the direction of the cross product, because after the great in a great explanation of the vectors product, we will know that why we put in as a unit vector here after the product, because it shows us the direction when a vector a and b are cross with one another. So this in may be positive or negative. Therefore, like dot product, where we can write dot product is a dot b is equal to b dot a. Okay, but in cross product we can't write here a cross b, b cross a. It will wrong, because a cross b is not equal to b cross a in a cross product. Why? Because of this n. When n is positive, sometimes n is positive and sometimes this n is negative. Therefore, however, we can write here like a cross b is equal to minus b cross a. Okay, inshallah I will discuss these topics in the upcoming chapter. The last one is the torque in vectors and in equilibrium chapters formulas. Here it is torque. Torque can be denoted by the word ta, and ta is equal to r cross f, where r is a moment arm and f is a force applied. I will write here only the force. Torque is equal to r cross f, where r is a moment arm, f is a applied force. Inshallah, we will apply these formulas in my upcoming chapter. which is a chapter of vectors and equilibrium, very easy but very crucial chapter in classical physics. Therefore, stay tuned with my channel Professor Academy, and hopefully you will have enjoyed today's lecture. Best of luck for the next time. Thank you for watching my videos.